Little Brian is back. So oh, yeah. Now, so sorry, start again. Now, as I was saying, I know you were saying there earlier that O will always come after W. That's what you were saying, yes?
Yes.
Okay, right. Then how come it doesn't do that for numbers? Nope. Okay. Okay. Right. I'll show you what I mean. So this one always prints off wolf. Okay. Always prints off wolf. Now I'm asking the question is why? No? Because just make sure this guy here, right? So I have done strings, parallel stream, reduce. This is it here. Okay. So there's a reduction. Now,
one thing that might be worth trying here is put those letters in backwards. Like FLOW, see where this stuff is.
you do get FLOW. Yeah, you will get FLOW. So I think I did that. Yeah, so we'll get flow. Right. Yeah, hold on now. So now I just want to get this fully clear in my own head first before. Okay, so I want to make sure that there is a problem. Right. So if I just go to print off numbers using parallel stream, it'll print them all over the shop. Yeah? Nice. If I go to print off this guy, no, not doing reduction, I'm just printing it off. So if I go strs dot parallel stream dot for each and system dot out. All right. So, right. Make this a print.
There's one difference there, though, in that case, you're doing it from a list, and above, you're not doing it from a list.
Numbers?
Yeah.
Numbers is the list.
Sorry.
Yeah, it is. Right. So if you're just accessing numbers using a parallel stream, it's going to access them all over the place. Okay. So just go here. Now, similarly, if you're just accessing strings, WOLF, it's going to access them all over the place. LYOF. Yeah?
Yeah.
Right. Now, here's the question. When I do use reduce in it, now the reason because it's a parallel stream. Fine. When I do strings.parallel stream, right? When I do when I go numbers.parallel stream, it can pick literally any number. Right? Yeah? Right. When I do strings.parallel stream, it's not picking literally any number. It's picking W, O, L, and F.
Do we know that the reduce isn't turning it into a regular string?
Well, what it's doing is, so it starts off as an empty string, okay? And it's taking any two strings and adding them up.
But is it any two? Because the reduce might turn it into a
But see, that's the thing.
So it's still
No, but you see, but here's the thing, right? Reduce doesn't care what you do here, right? The rule is, from the reduce up here, is that it picks literally any two numbers. Where is it? Here. This is parallel processing. Okay? This one is also parallel processing. So that means it should literally pick any number, any letters. So it's all right to say, oh, it might be creating a string. Why is it doing that? No, but yeah, that's what it's doing. But what I'm saying is, how does it know to pick W and O? No, no. It could easily pick O and F because it's random.
There's one difference there.
Yeah.
449.
449, yeah.
And 451. You have it put into a system out print line. Does that have anything to do with college whatsoever? You put system out print line before 449.
Well, see, here's the thing is, Kieran, right? So,
Just before keep it exactly the same.
right. So, this guy here is a parallel stream.
Yeah.
That means it can pick any, literally any string. Okay? Literally any string.
Yeah.
This guy here, that means the same thing.
Yeah.
Right. So it's reduced. Now it always starts off with an empty string. And it takes two of the strings. But the fact that it's a parallel stream means it can pick any two of them.
Yeah.
Not just W, O, and L, and F, which is what it's doing there.
Yeah.
So I want to know is why is it picking W, O, and LF every time?
Yeah, and that's just why I'm saying there is it has got the only difference between those two lines is one is in the system out print line. Another probably is nothing to do with it. Like 449. I mean, it shouldn't, but then you just don't do it.
No, it shouldn't. No, that won't make a difference. How would you actually print out that? How would you put that in a print statement? Let me just think. You couldn't really. And, right, just if I print this out here, it is printing out LYOF. And if I save them to an array list, right, watch this. So let's just say I'm going to create an ordinary So if I go strs dot parallel stream dot stream. Now I know this is awkward what I'm doing here. Dot map, and just takes in the string, returns a string, and then I go dot fuck off. Dot collect collector dot to list. It's not the pool either. That's nothing to do with that. So if I do that, and if I assign this to strs, create a new list of string str2, and if I print off str2, str2. Now that's printing off Wolf. I don't know. I don't know what the fuck. I don't understand it.
You try not dumping in as an array style aspect to create the array list and put the variables in.
Yeah, I'll try and do
It
this.
may make a difference, I don't know.
Right, so I'll do strs.add wo and l and f, yeah? Yeah. Or strs is equal to, no, strs.add w. strs.add o. strs.add n. strs.add f. Now, take out that guy. str parallel stream for each system output print is still giving us LWF, which is correct. But yet when I go down here, it's not. So I don't, because the reduce, when you're using reduce with a list of numbers, it can literally pick any numbers. Here it doesn't seem to be doing that. It seems to be picking W, O, L, F. And I don't know why. It should be producing something like that. I don't know if that's any use to anyone. Now, I can even try this. So that should produce string. String full str is equal to that guy. No, no. Wolf. That's only a small thing, but I don't know why. All right. Because with numbers, it's picking literally any of the numbers. Here it's not. It's picking W, O, and then L and F. And I don't know why. It's operating differently with strings than it is with numbers. And I don't know why. Now, if anyone can tell me why.
The combiner will be concatenate the strings, isn't it? all the time.
Well, here's what's happening, right? So we have W,
Yeah.
O, L, and F. Now, to show you what was happening with the numbers, we had 1, 2, 3, 4, 5, 6. Now, it could literally pick any two numbers, 6 and 1, then 4 and 2, then 3 and 4. Okay, 3 and 4 is 7, 2 and 5 is 7, 1 and 6 is 7, 3 sevens is 21. Doesn't matter how you do it. So when you're doing parallel stream with our array or with our list of numbers, was picking random numbers. Okay, now these are a list of strings. So I'm doing the same thing. It's actually the same syntax. Now it's concatenating, but it's just syntax. Now to prove, if I go str parallel stream for each system.println, it prints off that. Sorry, not that. Sorry, go back to here. Prints off that. Here, LFWO, which is what I'd expect. Because it's a parallel stream, that means it can pick literally any one of them. Okay? And it's going to go, in this case, it goes LFWO. All right? Now, and also, I did up here, just to show you, it does the same thing with numbers. If I just print off the numbers, it prints them all over the shop. 4, 2, 5, 1, 3, 6. Right? So them two are operating the way it should operate. All right? Now, if I use reduce on this guy, okay, the way it operates is it takes any numbers and it adds them up. Literally anyway. Okay? And you get 21. Problem with this guy is it's only taking them in the order they're there. It's taking WO and it's taking L and F. Actually, what it's taking is it's taking the blank string and W. It's taking O and L, and it's taking F, or something like that. Or it might have the blank string by itself. All right, and then at the end here, it puts them all together: W, O, L, F.
If you still know that having the, I know it, the 4.7 system of print line, it's a how to do the peak without heavy.
We'll see what's, well now, I'm fairly certain when I do the peak here, it'll be showing them all over the place.
Yes, small print, but that's why the difference I see between the two of them.
So if I put query here,
Yeah, it's a system of print line.
yeah, to do the same thing. All right. So I'll take out that guy. I'll take out that guy. I'll do a peak. Okay. So, and I will, this is new numbers, our strings. And that is printing off this one here. I need to do a just a minute now and make sure I'm in the right place. So our strings is printing off LWOF. So when you peak it, it is LWOF. But when you reduce it, it's producing WOLF. And I don't know why the fuck it's doing that. So see it there? LWOF. Can you see what I'm talking about? I don't understand why this is operating differently to the numbers. There's no earthly reason why, because that's the beauty of reduce. It doesn't operate differently. That's the beauty of computer programming. It doesn't operate differently. You know a rule, it operates that way. So there's something else happening there. I don't understand what. Obviously, if you don't understand it, it's not a good thing. It's only a minor thing. It actually makes things easier for us. No, 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 they're right. They're right. If it wasn't right, you'd be getting an error. So all it's doing is it's taking two numbers. No, no, we're not into collisions. So this is taking.
No.
What? Yeah.
In the full string, you didn't do the peak.
Well, yeah, I'll try peak there, so Priya, and see what happens. Okay. So I'll try peak. Now I'm fairly certain this is also going to produce LWOF, but we'll see. So all right.
No println. Print.
LWOF, same thing.
Yeah. Did you print println?
Yeah, print line, but it's still going LWOF.
Okay.
So I guess we'll just have to try and figure that out, but we'll come back to it. All right, we won't spend any more time with it. Say that again now? I wouldn't say it's identical to a for loop.
Well, it says here.
Oh, I know, I know. I mean, it has the same functions of a for loop, but when you get used to it, it's easier than a for loop. But what I'm saying here is, this is not operating the same as this one. Because if it's associative, it means it can literally pick any of those numbers. It's a parallel stream. So it's associative and it's stateless. So I can pick any of the. I did. Yeah, that one. So full string. Wolf. See there?
Oh, so it's coming in as LWOF.
Yeah, so if I have the peak, it's LWOF, but as soon as I reduce it, it becomes WOLF.
Because there are two.
Too hot.
Rush against contact reception. Tom, rush against contact reception. Thank you.
And exactly, yeah, they passed over really, really quickly because I wasn't 100% sure why I did that. If you look at the example of the book, they just show it and then they go on quickly to something else. I'm thinking whoever wrote the book that said, our frigate, no one's going to notice it. But guess what? We noticed it. That's only one thing, right? And we're going to do plenty of questions. So at the end of the day, if it comes up in a question, we'll find explanations for it somewhere. Okay? I don't know why it's doing it. And I don't really like that. Okay? Now, so there is other reductions. Okay? You can use the reduce function with Let me just see how I have it here. So there is another reduce function, okay? So it's called STRS, okay? So we can use this one. I got STRS dot, let me see if I got this right one. Dot stream. I'm just going to do a dot stream one for a minute. Okay, and if I go dot reduce,
It's not because it's zero, the other one's beginning at the rate, use a W.
no, that's a blank. Well, we're moving on from that now, so we're just going to leave it there in the corner. It's the problem child in the corner. We're going to ignore it. Okay, might let it out and not grunt, but we'll ignore it for now. All right. So this is a reduce method with just two things. Okay. So we start off with X. Okay. And what we just have an accumulator. And what we have in the accumulator is it takes in two variables and it concatenates the two variables. Now, so what will that produce? Now, for reasons we don't really know yet, we know that str dot, if we're just printing off strs, okay, this is going to produce WOLF. Yeah, right. Now, so it's W O L and F. Okay, so this is stream. This is an ordinary stream, so it doesn't have to be associative. It doesn't have to be stateless for it to work. Okay, so it starts with an X, and what does it do? It adds W O together, L and F together, so it produces X wolf. Yeah. Yes. Okay. So to prove that it does print off X wolf, I'm only doing this example because this is the example that's in the book. I don't think it's a very good example, but that's what they have in the book. Fine. No problem there. Now, if we use the same syntax for a parallel string, dot parallel string, and we're going to do the exact same syntax. Okay. Now what would this produce? XW, XO, XL, XF. Why it produces that, I don't know. Now, this is just to show you, if you're going to use reduce with the parallel stream, you use the reduce that takes 3 arguments. Don't use any other reduce because the results can be unpredictable. All right, you want to produce X wolf, right? The only difference between this guy and this guy is this is the stream. This is a parallel stream. Okay, now, so this produces X wolf. Okay, this guy produces, so you want to produce X wolf, but this produces. Now, why it does that, I haven't worked it out. I'm sure if we spend time on it, we could work it out, right? But I want to produce X wolf from a parallel stream. If you want a parallel stream to work like it does with an ordinary stream, you need to use the reduce that takes 3 arguments. So if I go like this, go strs dot parallel stream, and we go dot reduce. Okay, so we're going to start off with x. Okay, what are we going to do with each one? We're going to go A, B, A plus B. And then we're going to do another one. I'm going to do C, D, C plus D. Need to have a dot there. Right now, that should produce X wolf. Fuck it. Let me just see, parallel stream, C plus D. I'm not too sure. All right, I'm gonna just try. That's going to produce. Okay, all right. Well, the example in the book isn't even finished. All right. So let me just see. Because if you look at page 375 of the book, it just gives you the examples of XW, X0, XL, XF. It doesn't give you an example of how you would get X wolf. Okay. So definitely they're having a bad day when they're writing that. So now it's somehow linked again to why it produces WOLF instead of random. So I need to find out. So this also produces this. So I will have to figure that out as well. Just comment on this guy, comment on this guy. Yeah, so I don't know why.
Hold on. So all that stuff we were doing before with the common child,
Yeah.
our starting position was actually just blank. So that was
Yeah.
actually, it was being added. We just didn't see it. Is that right?
So this one here.
So it was blank W, blank 0.
Yeah, so it was blank W, then it goes, yeah. Well, no, blank, it's not blank, it's, well, no, it's not, no space in it. Well, it is a blank.
That's what I mean. Yeah, that's why we're not seeing it. We're just seeing both. But it is actually there, right? It's just like with the X's. So you have XW, X.
Oh, down here?
Yeah.
Right, so this one here we're talking about.
Yeah, we're talking.
Yeah, well,
there with the X's.
that one is easy.
Yeah.
That one works as, you know, okay? Oh, hold on.
I mean, with the parallel.
Hold on. I'm missing one here. Just go here for a second. Hold on a second now. C, D, and that's C plus D. Fuck off. Fuck us. Huh? Oh yeah. No. Yeah, so same thing again. So I don't fucking know why. Anyway, so we'll have to figure that out. I'll spend an hour tomorrow morning and see if I can figure out what's happening there. But we can go on to another type of reduction, which is collect. Okay, we can go on to another type of reduction, which is collect. Now that is EX9. So we got static void EX9 or 10. Love isn't bad. Now, what they advise when you're doing a collection, okay? So just like with the reduce, the one they advise you to use is the one with 3 arguments, okay? So let's put it in here. So this is combining results. Jesus, I wasn't recording it. Lads. Oh no, I was. No, it's all right. It's all right. So combining results with collect. Okay. Now, so it is advised to use the 3 argument collect method when using with parallel stream. Okay. Now, to give the example of the wolf here again, so I'm going to try it with wolf, and I'm also going to try it with numbers. Is that okay with everyone? Yeah? Right. Now, so, first of all, now I'm actually going to create a stream here. I'll try it this way first, then I'll try it with a list and making a parallel stream out of the list, and we'll see do we get the same thing. So stream, string, stream is equal to, now it's a long time since we use this, but we can, stream of W O L F. And we go dot parallel. That's a parallel stream. Okay. So that's a parallel stream by itself. Okay. By having the dot parallel stream operation, this makes this parallel stream. Okay, so I'm going to go down here. Now, I know how this works. I know why this is doing what it's doing. So I'm going to do a sorted set. This can be sorted set of strings set. Now, so I'm going to import that, and I'm going to import, oh no, I haven't done anything with that yet. So, stream. Now, it's this guy. This is a parallel stream. So I don't have to say stream.parallel stream because it already is a parallel stream. Yes? Yeah, okay. So, dot. Now it's the collect. You can see there is 2 collect methods. Okay. Now, so now it calls it here a supplier, but it's basically the same thing. It's basically identifier as well. Okay. The second one is the accumulator, exactly the same as a reduction. The third one is a combiner, which is exactly the same as in a reduction. Okay. Now, what we're trying to do is we're trying to save all of these letters to a collection object, which is sorted set. All right. Now, what you put in here is what sort of set, map, queue, or list you want there. So a sorted set, that means it's going to be sorted in an order. All right. Now we want, so sorted set itself is not, that's an interface. So it's not thread safe. Now, there is a class that implements the sorted set interface that is thread safe, and it's this guy. So I'm going to go new. So it's new, concurrent, skip, list, set. Now, that's a thread safe tree set. That's what that is. Okay. That's a thread safe tree set. So we create a thread safe tree set. Now, what are we going to do to each of these items? Okay, WOLF. We're going to, so we're going to go SE, S, and we're going to add, so SE is the sorted set, S is the string. So what are we going to do? We are going to SE dot add the string. Okay. And now, if you don't include this one, it causes problems. All right. So if you don't include this one, it will cause problems. It will cause it can cause your set to go all over the place. When you're adding to a list, you just need to put in this as well. So we go SE, S. Now you can call them anything you want, obviously. And so SE is because I'll explain in a minute, SE.add all S. Now I need to import that. Now, what this is doing is it adds W to the list. All right. Next time it's going to add WO. All right. Now, I can't remember, why does it have to do SE add all? Can anyone remember why we need to do add all there? Can anyone remember that?
Because they're lists themselves, aren't they? They go along.
So WO is a separate list.
Yeah.
And you need to add that list to that one there, isn't that it? Something like that, yeah, something like that. Okay, now that will create WOLF. Okay, simple reason, because it's a concurrent skip list set. So there's an order in it. All right, so what will that print out? Sure, it prints off. So I'm going to print off what's that going to print off? Is it going to print off WOLF? Remember that this guy is the equivalent of a tree set. What do tree sets do? What do tree sets do to strings, for instance? If I have,
No duplicates.
that's the first thing it does. What else does it do?
Kevin Daly, contact reception. Kevin Daly, contact reception, please. Thank you.
Jesus, I say Kevin heard that, am I? Okay. What does it do? Sorts them in alphabetical format. So it's not going to print off wolf. It should print off F, L, O, W. A, B, C, D, F, G, H, A, B, C, D, F, G, A, B, C, D, F, G, H, I, J, K, L, M, N, N, O, P, Q, R, S, T, U, V, W. Okay, so it should print off F, L, O, W. go here. Oops, EX10. Flow. Okay. All right. So what is this guy? So collect. So I'll put it in here. Collect takes 3 arguments. Now, this is still an identity, really. Okay. This is still an identity. Now, I don't know what does it call it when I do it. Let me just see. They just call it a supplier, but it is an identity as well. So it takes 3 arguments. Supplier, which is a supplier. And the object, you will save the stream values to, in this case, a thread safe collection, a concordant skip list, which is a thread safe tree set. Okay. Second argument is an accumulator, which is a buy function. Okay. Takes 2 elements and does something with these elements. In this case, takes a set and a string and adds the string to the set. Okay, so what set? So SE is that set. S is each one of those strings, W, O, L, and F. Okay, the last one then is combiner, combining all the strings to one set.
Any of that node it doesn't give low, gives F comma, why is it just in commas there? But
Because that's a set. It's not a single string. It's a set of strings.
oh yeah.
First string is F, second string is L, third string is O, fourth string is W. Okay? So it's a set of 4 strings. Okay? Now, if we create a list, we should also get the same thing. So if I create a list, string, list is equal to new array list. And I'm going to put in this guy here. And I am going to go, I'm going to set that clear first. I'm going to go set is equal to list dot parallel stream dot, I put in the exact same thing. We should get the exact same answer. Okay. So now for print off set, I should be getting the same thing. Yeah. Okay. So they're both parallel streams. This is creating a parallel stream of parallel. Here I'm creating a list, and from that list I'm creating a parallel stream. You could even do something as, yeah. So it works fine. So I know how that works. It's the previous shit I don't know how it works. All right. So this produces this. Okay. So this organizes letters in alphabetical order. So this becomes F, L, O, W. Okay. So from W, O, L, F, we get F, L, O, W. Okay. This also produces F, L, O, W. Now, so if I come down here, now we can use the one argument collect method. So this is using the three argument collect method. All right. You can also use, now the one argument collect method, it's not advisable to use it. All right. So let me just go here. So this is static void ex11. All right. So I'm going to create this list down here. So this is using the one argument collect method. So you can use this. So let's see if I can do this right. So I'm going to go set string. I'm going to go set I'm going to go sorted set string. I'm going to call it set is equal to list dot parallel string dot collect. So it's this one.
Section, contact reception, apprenticeship section, a contact reception. Thank you.
Now, so
Galway room 1105, Tom Rashkin, the Galway room 1105. Thank you.
so we can do this. So I need to import that guy. Now, this is a shortened version of it. All right. So we go sorted set list.parallel stream collect collectors to collection tree set.new. Now that takes to collection takes a supplier object. That's shorthand. All right. If you want to do the longhand, what you do is and we go and I go new tree set. Same thing. So then you have a new sorted set. You could print it out. This is this one here. This is EX11. Now, despite all this, they do recommend you use this version instead of this version. The main reason is it adds more control. Now here it's fine, all right, because this is going to display FLOW because it's a tree set. All right, if that wasn't a tree set, so let's say if it was a so I'll import that. Now, of course, that is not sorted set. So I'll import that. And if I print that out, it's all over the shop. All right, so here's the upside of it. All right. Yes, you can start using your parallel stream and can use the three argument collect method, or you can use something like a tree set. So that would be a sorted set. New tree set. And that'll organize them FLOW. I'm just showing you all the ins and outs that are going to ask in the exam. But in all honesty, that's sufficient enough, really. Now, it says, it does recommend that if you're going to use the collect method with a parallel stream, this is the one you should be using. You should be using the three argument version. Okay? And there's also another reason as well. This is slower than this. All right? This guy here is slower than this because this guy here is for usage in parallel streams. This guy isn't. Okay, this sort of method here, that method is for generally creating any type of list, whereas this method here is more specifically for parallel streams. So this is faster. This collect method is the recommended one you use when you are using parallel streams. This collect recommend using your parallel streams as this is specifically designed for parallel streams. Okay, as this is specifically for parallel streams. Now there's a whole section here about something called characteristics. I don't see why it's included, so I'm not going to do it. All right, I might come back to it. All right, so this is the last part in this section. So this is using the one argument collect method. Let's put in here. So this is the sorted set. Set is a list of parallel stream collect collectors to collection new tree set. That is the single version. Now that's doing a control set. But let's say if I did this instead, I went list string list is equal to list2 is equal to list at parallel stream dot collect. Fuck you. It's all right. So if I go collectors dot to list It's another shortened one. Okay, now both of these versions are going to be slower than that guy. Okay, both of these versions are going to be slower than this guy. Not because it's a concordant skipped list set, it's because this method can apply to both. It's designed for all types of streams, okay? Whereas this one is designed with parallel streams in mind. That's the only reason, really, as far as I know, okay? So this is the advise collect method, whereas this one is not the advise collect method. And of course, this is a list. So this is going to be as entered. Again, there it is again, right? I don't see why that's wolf. Because it's a parallel stream and it's just taking the random strings from W, O, L, and F. And yet it's producing W, O, L, and F. I don't know why. No, it's not random. But yeah, I know that, but why? Because it was that's not the case with numbers, which makes sense. Because if that was the case, then the numbers would be all over the shop when if that's the case, when I print off the numbers, it should be going 1, 2, 3, 4, 5, 6, but it's not. It's printing them all over the shop.
Because you don't have to mark it. Because there is no number of 8.
No, it's not to do with that. Anyway, I'm going to leave it because I don't know, to be honest. Okay. Now, so there's a whole section to do with characteristics here, and I'm not too sure what they're even about. It's in the book. You can have a look about it if you want to, but I'm not really sure what. I don't see what you actually use it for because it doesn't give an example of what you use it for. So I don't know what characteristics are. I don't know why you use them. So I have it here, but it's just kind of showing various, I don't know what they are really. So I don't know. Anyway, this is the last section. This is static void ex12. Now, I am going to create a list of strings. So I'm going to go list string. I'm going to call it animals is equal to new array list, and this is going to be line, and it's arrays dot as list, and it's going to be lines. It's going to be tigers. It's going to be bears. It's going to be leopards. It's going to be wolves. And it's going to be sharks. Right? And just to show you that it prints off. So this ex12. So print off, fine. All right. Now, so let's see. Now, did we do concordant maps before? Can you remember? Can I remember them?
Sounds familiar.
Okay. Right. I can't remember doing them. Right, I suppose I'll just have to explain them. All right. So I am going to go concordant map. I want to import that. Did I spell that wrong? Concordant map, integer, string, map. Now, so I don't know if I did this before. All right, so a concordant map is a thread safe map. All right, that's what a concordant map is. Okay, so concordant map. I don't have it there. Concordant map is a thread safe map. So it only one thread can access at a time. So all the values inside it are atomic. Okay. All the keys are atomic, all the values are atomic, which means only one thread can access them at a time. All right. Now, so how do you use these in conjunction with a parallel stream? All right. Because if you have a thread, think about you're kind of operating two different things. Parallel stream can access any of the items, can access all of the items at the same time. Whereas a concordant map can only access one item at a time. So there has to be a bit of translation going on here. All right. So I'm going to create a parallel stream from animals. So it's equal to animals dot parallel stream dot. Now, so what do you need to do to this guy to turn it into a concordant map? Now, why they show this? There's plenty of other maps, by the way. There's plenty of other collection types. So they're just picking some of them. There's a lot more than the ones we're showing, right? You can even design your own. There's specialized ones out there. There's specialized types of collection objects. You could have a collection object that only takes, let's say, some settings from a graphics card. Okay, so these are all going to be specialized collections. You can make your own collection object as well. So there is literally hundreds of thousands of different collection objects out there. These are just some of the ones that come pre-packaged with Java. All right, so you can create your own if you want to. Concordant map, integer map, animals.parallel stream. So what do we need to do? I need to go collect. Okay, and we're going to go collectors dot to concordant map. Okay, now if in doubt which collector to use, you always use the one with 3 arguments, which I think is that one. Oh no, it's definitely not that one. So that's the one with 4 arguments. So it's the one above it. So I'll do that again. So I will take out that. So it should be that one. Okay. Now, to concordant map. Right, the first one. What do we want our key to be? Okay, what do we want our key to be? So remember, now a concordant map is quite simply a hash map that's thread safe. That's all it is. Okay, so it's the same, it operates the same way as toMap. So you have a key mapper. So remember, the keys have to be unique. Okay, now, so yes, I know some of these aren't unique. Let me just see. Yeah, right. Now, what I'm going to use as the key is the length of the string. Now, straight away, you can say, hold on a minute, lines is going to have the same key as bears. Yes? Because 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Sharks is going to have the same key as tigers and wolves because they're both 6 characters long. Leopards is 8 characters long. Okay, I'll show what happens. All right. Now, so I put in as the key mapper. What I'm going to do is, so it takes in the string. Okay. And what does it do? It gets the length, so S dot length. That's going to be the key. Okay. What's going to be the value? It's quite simply the string. So I'll actually call this K, and I'll call this K dot length. I'll call this one V, and we're going to return V. Now, the last part, this is just how you want to display it. It's the best way to describe it. Okay, merge function takes a by function. Okay, it takes a by function which takes in the key and the value, and it returns the key plus comma plus value, second one. Okay, now what does that produce? So we start off with our 6. So lions, bears, lions and bears both have 4 letters. Okay. Now tigers, so that's 4. Tigers, which is 5. That's all by itself, isn't it? Well, I'll just print it off and we'll see. Okay. So if I go off here. Now, a concordant map, what it does is it groups our values. Right? Remember those boys from before? Okay. That's what it was. Yeah, we did do it before. I remember it now. Okay. So it groups the values. So the key is what groups the values together. What is the key? The amount of characters. So there is 5. There is 2 there's 2 strings with 5 characters in it. There is 3 strings with 6 characters in it. There is 1 string with 8 characters in it. And sorry, I know what this is. This guy here, this is the dividing line between lions and bears. Now, if I changed it to dot, see the dot appears. You can even put in a word. And bears and lions, sharks and wolves and tigers, leopards. Okay, so that's the separator. That's what you're putting in there.
So we just have the one value.
Yeah, yeah. Okay, so now it wasn't a concordant map when we were doing the collection. It was called something else. I can't remember which one it was. Okay, now this is a thread safe map. Okay, so if it is a thread safe map, that means you are going to lose some of the benefits of a parallel stream. All right, actually, no, you won't. It could be checking all of the same strings at the same time. So you will actually gain something from this. All right. There is going to be a parallel processing going on. It sees that lines So it checks lines, sees it as 4. At the same time, it might be checking leopards. But leopards has got 8. So it assigns 8 to leopards. Then it checks, let's say if it's checking this string, tigers and bears. It sees tigers as 5, but sees bears has 4. So you're still getting some of the benefits of parallel processing. All right. Now, so this is a thread safe map. Okay. This is probably what should you use. If you're going to use map with the parallel streams, this is probably what you should use. Okay. Now, what does the concordant map produce? Or how does it work? So takes a function. Takes a function which will be the key. Takes a function which will be a value and the separator in this case, and a binary operator. Okay. So binary operator means it takes 2 arguments and returns 1 object. Okay. Now,
That's what's making the values.
sorry,
That's what's making the value, isn't it?
the second one, that's making the value.
The third one, because it's combining them all together into one value.
Oh, it is, yeah. Sorry, yeah. Sorry. Okay, so takes 2 arguments and return object. This is what produces 5 is equal to bears and lions. Okay, so that's the key, that's the value. Now, if 2 values have the same key, it's going to put and in between them. Okay, so this is the key, this is the value. So if 2 values have the same key, they will be combined with the word and. Okay, so this should really be V1 and V2 because they're both values. Okay, now we're nearly finished this fucking thing. This bit of Jesus. Now, just to show you, you can also do it with an ordinary stream. This guy here, so I'm just going to copy and paste it in because it's easier to do that. So stream.iterate, it's going to go start off at 0, and then it's going to go to 1 multiplied by 2, 2 multiplied by 2, 3 multiplied by 2, 4 multiplied by 2, 5 multiplied by 2, 6 multiplied by 2, 8 multiplied by 2, 9 multiplied by 2, 10 multiplied by 2. Okay, then it's going to go to map. All right, and so this is just a basic to map, so that's the key. Okay, that is the value. And then here, this, so if you have 2 keys the same, it's going to concatenate them. All right, so print that out. Why is it going number 0 10 times? Why is it doing that? Yeah, it's gone up by 2. Yeah. Strange. Okay, now that's just an ordinary map. That's not a concordant map. All right, that's just an ordinary map. That's what I'm going to do here as well. Right, that's that section done. Now there's only one thing I have to cover, finish in that section. It's a bit above it. I was coming up with something weird and strange. I don't know how I've done it. All right, so I will have to come back to that. So hopefully tomorrow morning I can go back to that. All right, so I'm going to just stop that video. Now there's 1 or 2 other small bits of code. I'm going to copy and paste them into it. There's nothing really of consequence in it at all. All right. So I'm just going to